started. So you can see here operational amplifier. In short, it is known as Opamp. It is actually a general purpose amplifier. Why it is known as general purpose amplifier? Because when we are adding some extra components like resistor, capacitors, voltage sources, current sources in some specific way in a circuit, we can design multiple application through the op-amp. As like we can design adder circuit, we can design subtractor, we can design multiplier, we can design squarer circuit in digital electronics, also in analog electronics. We can design amplifiers, and many more applications are there, as like you can say oscillators, filters, comparators, regulators, etc. Right? And this is the reason they are known as general purpose amplifier. And it is actually a multi-stage amplifier. So the difference between a single stage and multi-stage amplifier, you have studied multi-stage amplifier in your second semester in basic electronics. It was looking something like this. It is the voltage divider bias multi-stage single stage amplifier, right? So for example, let's say the gain of this amplifier is beta 1, and let's assume that gain of this another amplifier is beta 2, right? Then when we are going to cascade both the amplifiers, at that time the overall gain at this point output, the overall gain you will get, it is beta 1 into beta 2, right? So your gain will be multiplied. So when the higher gain is needed, at that time we are using a multi-stage amplifier, right? You can add number of amplifiers as per your requirement. Operational amplifier is also a multi-stage amplifier, and it consists of 4-stage amplifier. Now in a multi-stage amplifier, it may be that all the amplifiers are of the same type, or it may be that all the amplifiers are of different type, right? So if you are checking out the block diagram of the op-amp, you can see over here the first block is the input stage. The first block is actually the input stage, and this block is actually dual input balanced output differential amplifier. Dual input, it says it has two inputs. Balanced output means number of input is equals to number of outputs. So here two outputs are there, and differential amplifier, it says that your output is gain multiplied by difference between the two inputs, right? Difference between the voltages of the two inputs. So it is known as differential amplifier. Now the output of this first stage is provided to the intermediate stage. Now this intermediate stage is dual input unbalanced output differential amplifier. Now as it says, dual input means it has two inputs. Unbalanced output means number of inputs is not equal to number of outputs. So here we have one output, and it is a differential amplifier, as your output will be gain multiplied by difference of the two voltages of the input, right? The drawback of this kind of intermediate stage is that while amplifying your signal, your DC level will also be changed, right? And we don't want to change our DC level. We want to make our DC level to the zero itself. And for this reason, the next block is the emitter follower, right? It is the level shifting stage. As we know that emitter follower gain is 1, right? So the gain will not change, but the level of your output will be changed. It will be across the zero line. Then finally there is one output stage, and it is a kind of push-pull amplifier, and whatever the output is there is taken out from this output stage. If you want to check out what is the differential amplifier, you can see here. This is the diagram of a single differential amplifier. in which we are going to use two inputs, two transistors Q1 and Q2, where two inputs are provided, input 1 and input 2. Outputs are taken out from the collector terminal V1 out and V2 out, and both the transistors are connected back to back, and this is the reason your output here, your output, which is the difference between these two, is equals to output equals to gain multiplied by V in 1 minus V in 2. Right? Your output will be V in 1 minus V in 2 multiplied by gain. So op-amps are capable of to do addition, subtraction, multiplication, and so on, whatever I have just described. This is the schematic symbol of the op-amp. Op-amp ने कई रीते design करूँ, right? So it's a triangle, as one of the input will be inverting and another input will be non-inverting, right? So the non-inverting terminal, we are calling it V1, and inverting terminal, let's call it V2, right? It just says when you have two, one in non-inverting and other inverting terminal, the output will be the difference, right? Actually what you are going to provide is the difference of the two inputs, right? And this whole structure is shown over here. What is the actual circuit inside this, right? How these four structures are there, four blocks are there. So here you can see the first block is dual input balanced output differential amplifier, whatever I have shown, right? And the output, here you will have two outputs, and these two outputs are fed to the next intermediate stage, right? And this intermediate stage has only a single output over here, you can see here, right? And this output is provided to the emitter follower, the third stage, and the output of the third stage is again given to the push-pull amplifier, right? And output of the push-pull amplifier will be the output of your operational amplifier. So it is the basic MC1435 op-amp. Actually, this whole circuit is actually fabricated on a silicon chip, right? We are not going to make an op-amp on the PCB. Instead, we have an IC in which all these four stages circuitry is actually manufactured, fabricated inside it, right? And it is a 8-pin IC. This is the 8-pin IC, somewhat like this. So we know that here you can see in the block diagram, you can see we have two inputs and one output, right? So three pins are provided, two inputs, non-inverting, inverting, and one output. Then why other, right? As we have 8 pins, right? And only three were provided in the block diagram. What about other five? Then we can say that one of the pin will be your supply pin, right? You can see here in this diagram, one of the pin is your positive supply, which is VCC plus, right? And another you can see here, it is this is VEE minus, right? So two pins will be there. So 3 plus 2, 5 pins are there, right? One is not connected, and two more pins, offset null 1 and offset null is 5 offset null. There are pin number 1 and pin number 5. What is this offset null? You can say that when you have not provided any type of input to the operational amplifier, at that time also there will be some potential difference between the two inputs, right? Though this value may be in terms of microvolt and or millivolt, right? उसकी value बहुत कम हो सकती है, but then after it may play an important role in the output, right? So before proceeding to the applications of op-amp, right, उसकी अलग सर्किट बनाने से पहले हमें क्या करना चाहिए? We will have to nullify this inbuilt voltage, right? And to nullify this inbuilt voltage, we are provided with two pins, offset null, offset null. One is positive will be, another will be negative, right? So to nullify this effect, we'll have to use the offset null. Is it clear? Did you get it, students? Yes or no? I
Yes,
can't
ma'am.
hear. Okay, fine. So as I have told you that this all these things come in the IC package. All the four blocks actually come in the IC package. So you must know which type of ICs are available in market, right? So there are different packaging ICs are also there, right? So you can say general purpose op-amp. Basically, two general purpose op-amps are used, which are IC741 and another is 351. Both are general purpose op-amps, right? And some special purpose op-amps are also available, as like you will have if you want to use this op-amp in some very in the environment where temperature is very high, right? Or you can say where magnetic effect is more, right? If it is the military applications, right? So at that time special purpose op-amps can also be used. And second, special purpose op-amps, one example is CM 380, right? Also when you are using some higher voltages, right, and power application, at that time you will have to use the power amplifiers, right? So a simple general purpose amplifier cannot work over there. So for that purpose you will also have to use the special purpose op-amp, right? Now the types of IC, mainly there are four types of IC. The first is known as SSI. Do anybody know what is the full form of SSI? Anybody? No? Full, it is small scale integration. Small scale integration. So when in any IC the number of components is less than 10, right? In very earlier time in 1960s when ICs were come up, right, at that time the number of components were less than 10 inside it, and they were called small scale integration. Then another one is MSI. It is known as medium scale integration. If the number of components inside it is less than 100, you can say this type of IC is known as medium scale integration. Then comes LSI, which is known as large scale integration, where number of components is greater than 100 but and less than 1000. They come into the category of large scale integration. And the last one is known as VLSI. You are also going to study this whole subject in your next semester, is known as very large scale integration, where number of components in a single IC, you can say it is 2 centimeter by half centimeter size, right? So it is greater than 1000, right? It may be in the lakhs. Nowadays it comes in the number of lakhs, right? So as there is no limit right now, this technology is growing more and more, and that's why the technology has incorporated more and more number of components inside a small size of IC, right? Okay. when you are going to purchase the IC, at that time there will be written some number on it, right? Some number will be written on that. For example, IC number is MC34001, then comes P and उसके बाद लिखा होता है temperature 0 to let's say 30 degree, right? What does it mean? इसका मतलब क्या है, right? It just says MC. The first thing, it is the name of the first thing is the name of the manufacturer. What does it indicate? कि IC का manufacturer कौन है? So it is manufacturer, right? Then the number of the IC is there, and this number indicates the type of the IC. ये कौन सी चीज की IC है, right? So this indicates the type of IC, or you can say application of the IC. Then comes P. P says it is the plastic packaged. What does it say? It is the plastic packaged. And then comes the temperature range, that this application is good to run at the temperature between 0 to 30 degree. Are you getting this? Let's take another example of the IC is, let's say mu A 741, which is our Opamp. Then T is there, and finally C is written. What does it mean? Right? So again here UA mu, actually this is a mu, right? But here, yes, I will have to use the symbol. Mu A 741 is the IC type. Now what does the T says? It is the package type, and here it is mini DIP package, right? is यहाँ पे वो plastic package था, यहाँ पे it is a mini DIP. Mini DIP का मतलब क्या है? I will just tell you. Right? And finally C. What does C say? C says that it is the commercial temperature range. Right? It is commercial temperature range. Got it? समझ में आ रहा है? So temperature range कितनी हो सकती है? Right? Let's say अगर वो मिलिट्री के लिए हम यूज कर रहे हैं, राइट? तो टेम्परेचर रेंज कितनी होगी? अगर मिलिट्री के लिए हमें कोई आईसी डिजाइन करनी है, then your temperature range should minus 55 degree to, it should range to minus 55 degree to plus 125 degree Celsius, right? If it is used, it is to be used for the industrial purposes, then this range should be minus 20 to plus 85 degree Celsius. And if you are going to use it in the commercial application, then your range will be 0 to, you can say 70 degree Celsius, right? Okay, so you will have to check out for what purpose you want to purchase the IC, right? Now whatever the IC may be, right, there are many different types of manufacturers available in the market. you can say it's like Fairchild, right? As यहाँ पे जो लिखा है, it is mu a का मतलब it is not microampere, right? But it is the Fairchild company's identification, Fairchild. That Fairchild has developed this, right? तो Fairchild के लिए जो लोगो हैं, right? तो म्यू ए के ऊपर से हमें पता चल जाता है कि ओके दिस इज मैन्युफैक्चर्ड बाय Fairchild. Or sometimes you can also use mu AF. Sometimes mu AF is also written instead of only mu AF can also be written. So you can understand, okay, this is the kind of a Fairchild fabrication. Okay. Then national semiconductors. So if national semiconductors are manufacturing the IC, their IC number, your IC number will always start with either LM or LF or TBA, right? So for different type of ICs, they will use different type of starting address. Okay. If it is Motorola, if Motorola is fabricating the IC, designing the IC, right? Then starting will be MC or it may be MFC. Okay, it is Motorola. Then if it is manufactured by Texas Instruments, then SN1. If it is Burr Brown, right, it will start from BB. So from the starting of the name of the IC, you can just find out which manufacturer has designed and fabricated this, right? उसके बाद आता है number of the IC. Now see, कोई भी बना ले, कोई भी कंपनी, कोई भी इंडस्ट्रीज अगर ओपैम्प बना ले तो वो उसका नंबर हमेशा 741 ही देगा कंपल्सरीली, राइट? तो आप कोई भी कंपनी की आईसी परचेज कर लो, लेकिन 741 ऑलवेज इंडिकेट्स इट्स अ ऑपरेशनल एम्पलीफायर, जनरल पर्पस ऑपरेशनल एम्पलीफायर. ओके, तो 741 से आपको पता चलता है व्हाट इज द एप्लीकेशन ऑफ दिस आईसी. Then comes T. T says it is the package type, right? So there are number of package types available. So here I am showing you mainly three types of package. The first one is known as flat pack. The other is known as metal can or transistor pack. And the last is known as dual inline package, right? So it is the flat pack, right? You can see here as the pins are flat, right? And when you are going to insert it in the PCB, अगर आपको उसको PCB में लगाना है, you will have to just bend the legs, right? Keeping in mind not to break them. Okay. Now in this IC, you can see number of legs are there, number of pins are there, right? So in the specification, or you can say data sheet of the IC, specific IC, right? All the configuration will be given. What is there inside the IC, how the internal structure of the circuit look like, what is the characteristic of all the circuits inside the chip, right? At what temperature it will work best, at what different voltages it will work, right? And what will be the pin configuration. Finally, what we need is the pin configuration. So all these things are already provided in the data sheet of the IC. So before purchasing the IC, you must see the data sheet of the IC कि आपको कौन से पर्पस के लिए वो परचेज करनी है. Okay. Now as you can see यहाँ पे number of legs हैं. Then how will you identify that from where to start my numbering of the legs, right? as you can see in our last lecture, what I have shown you right here. It was the IC pin configuration of IC 741, right? So अब ये counting हमें कहाँ से start करनी है? 1 2 3 4 5 6 7 8. How will we count it? Right? To check this out, you can see here in this pin, यहाँ पे एक notch दिया गया है. One notch is there, right? So where the notch is there, उसके left side से you will have to count 1 2 3 4. राइट और यहाँ पे आप पहुंच सकते हो. Then on the another side you will have to start from the below, right? 5 6 7 8. So here two notches are given, one is over here and other is here. So you can just check out that okay, this is the pin number 1 2 3 4 and it will go down up to 5 6 7 8, right? So this is the flat pack IC. Then comes metal can or transistor pack. So almost all the transistor comes in this type of packaging. In most of the cases, it may be a plastic cage or it can be a metal can pack, right? Due to the metal can pack, you can say that transistors can work at very high temperatures also and very high voltage level, power levels. Because when we are using a metal case, right, it is more prominent for the heat sink. वो ज़्यादा heat को बाहर निकाल सकता है, right? And then finally is known as dual inline package. In short, it is also will be in a dual inline package, as we are using, you can say, microprocessor IC, microcontroller IC, or you are using RAM, right? So all these things comes in this in DIP package, right? Even our 741 IC is you can say DIP package, right? So here you can see that package type. Here when it is written as T, it is known as mini DIP, right? It is mini DIP, and finally temperature range is provided. Is it clear? Fine. So now we will have to understand about some terminology of the Opamp, right? You must know some definitions of Opamp, and I request all the students to just take a notebook with you and note down all these definitions, because we are going to deal with all these parameters throughout our syllabus. Okay? Some definitions. So the first definition is known as input offset voltage. So who will tell me? I have already explained what is input offset voltage. You can say that voltage that must be applied between two input terminals of op-amp to nullify the output is known as the input offset voltage, right? And for specific ICs, this range is also sometimes specific, right? All this range is also some specific range is there, and it cannot move further more from this. इससे वो ज़्यादा मूव नहीं कर सकता. So you can say अगर हम 741 यूज़ कर रहे हैं, right? sorry 7 then this value will be, it is indicated by VIO, V suffix IO. It is indicated by V I input offset voltage. IO means VIO, input offset voltage, right? And this is near about 150 microvolt maximum, right? It is 150 microvolt maximum. समझ में आ रहा है आप लोगों को?
Yes, ma'am.
अभिषेक, ओम, तन्वी?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
Okay. The second parameter, which is very important, it is known as input offset current. I request all the students to just note down these definitions because we are going to deal with this. Input offset current. Right. And actually it is denoted by IIO. It is denoted by IIO. Now you can see that, you can say define it as like it is the algebraic difference between the currents into inverting and non-inverting terminals is referred to as input offset current, and it is denoted by I suffix IO. I input offset current. And actually you can also say that this value will be IB1 minus IB2. You will call it IB1 minus IB2. And as it says that it is the algebraic difference, we will have to just take the amplitude, right? Okay. So where IB1, what is IB1? And what is IB2? So IB1 is the current to non-inverting terminal and IB2 is the current into inverting terminal, राइट तो ये जो ऑफसेट वोल्टेज की वजह से जो हमारे पास करंट मिलता है, राइट ये जो ऑफसेट वोल्टेज है उसकी वजह से दोनों टर्मिनल्स में जो करंट फ्लो होता है दैट इज IB1 एंड IB2 और उसका जो डिफरेंस है इट इज नोन एज इनपुट ऑफसेट करंट. Then comes the third definition. The third parameter is known as input bias current. Okay. This value of input offset current is specifically near about, you can say, 200 nanoampere. Right, minimum कितनी होगी? It is the minimum value 200 nano ampere minimum. Right? And for 741, this value is 6 nano ampere. Right? For 741, इसकी value कितनी है? 6 nano ampere. So sometimes if it is not provided, you can take it as your information. This value for 741 is given as 6 nano ampere. Okay, input bias current. The next parameter is input bias current. It is the average current into inverting and non-inverting terminals, right? And this is denoted as IB. I and in suffix capital B, right? And this value is given as IB1 plus IB2 divided by 2. Is it clear?
Yes, ma'am.
Okay. And for 741, this value is near about 500 nanoampere maximum. You can go up to minimum 500 nanoampere. Now, what is the difference between IB1, this one, and this one? Right? The difference is what? This is the average current. This is the average current. You can say when you have given some input. This was due to the offset. And now you are going to give the input voltage, and due to that input voltage, you will get some input current, and average of both is known as input bias current. Right? So it is the difference between the offset current and bias current. Next parameter is differential input resistance. It is the equivalent resistance measured at any input with connecting the terminal to 0 or ground. Right? It is the input resistance measured at any input with connecting other input terminal, with other terminal, not with other input terminal to ground. Right? So अगर हम inverting terminal पे ये measure करते हैं, then you will have to consider, you will have to ground the non-inverting terminal, and if you are considering it non-inverting terminal, then you will have to ground the inverting terminal. For the 741 IC, this value is near about 2 mega ohms. And it is indicated as capital R suffix I. Right? And for 741, this value is near about relatively high, up to 2 mega ohm. Okay. अगर हम FET Opamp यूज कर रहे हैं तो उसके लिए ये वैल्यू और भी ज्यादा रहेगी. इट विल बी इन टर्म्स ऑफ गीगा ओम्स, right? It may range up to the giga ohms, right? Okay. The next terminology, fifth, can say it is input capacitance, and it is denoted as capital C suffix I. Let's first note down the definition. It is the equivalent capacitance that can be measured at the inverting or non-inverting terminal with the other terminal connected to ground. तो जैसे हम रेजिस्टर मेजर करते हैं, सेम वे हमें कैपेसिटेंस मेजर करना है, right? And this value, its typical value is given as 1.4 picofarad. Pi is typical value is so I'm not writing equal to, right? 1.4 picofarad. So I think it is clear to all up to these definitions. In next lecture we will go through some more definitions, some more parameters, because in one lecture I think you will not be able to get all these things. Is it okay?
Yes, ma'am.
और यहाँ पे अगर कुछ समझ में नहीं आया है then you can ask me. If anything is not understood by anyone, everything is okay? So I am turning off.
Yes, ma'am.
And मैं ये जो sorry, ये जो PNG है, I will just upload it into the Teams. You can just go through it.